Lesson 5.4, linear equations, but now we're doing what's called just the number of possible solutions. This is actually going to be a pretty quick and easy lesson, I think, for you guys. But yeah, let's jump into it. So if we look at this example, right? So let's say we're just like answering A, B, and C. All right. So if it says determine the solution of each of the following linear systems. So let's solve A. Okay. So the way we do that, we could do it either way, right? Where we could do it using the substitution method or the elimination method. And if you do that, you know, you'd go through it and we'd end up getting y is equal to 4 and we get x is equal to -1. Okay? So fair enough. How many solutions are there? Well, there's one, right? The solution there would be at the point -1, 4, right? So x is -1 and y is 4. All right, so fair enough. So there'd be one solution there for pretty much all the ones we've been doing in the last lessons. But let's look at B. So in B it says, all right, so we solve these ones, doing it by elimination, right? So in this case, what we did is we took this, right? This -2x minus 3y minus 5. That's what we were dealing with here, right? Multiplied the whole thing by 2 so that we could cancel the 4x, right? So once we multiply everything by 2, it looks like this. But then look what happens. If we go 4x plus -4x, okay, that's 0, so the x's cancel. But then the same thing happens with the y's. And the same thing happens with the constants on the end too, right? So we end up getting an expression saying 0 is equal to 0. Well, that's true, but what does that mean, right? If we rearrange these two equations, right? So these are the two equations from B. And we rearrange them so we have it in the form y is equal to mx plus b for both of them. Then you can actually see that these are the same equation, right? And it's actually not that confusing, right? You can see if I divided this top equation by -2, right, on everything, it's -2, -2, -2, I would get this equation from below. So they are the same equation, right? That they're, you know, because you can do, as long as you do the same operation to every term, you know, you're not actually changing the equation. So these are the same equation. So what's happening here, you can imagine, well, you know, what we would say then for this one is that, so if we had, let's say, you know, our grid, and this is our first line, so, you know, maybe like this, right? That's our first line. Well, then the second line just is the first line. So you can think about both them as being like right on top of each other, right? They like are the same line. So how many solutions are there here? Well, you can think of any individual point along the way as being a solution. So there's actually an infinite number of solutions, right? They're like stacked on top of each other there. So if they end up being the same equation in the end, or if you solve for it and get 0 is equal to 0, then you would say that the system has an infinite number of solutions. Another way to say that is that you'd say the equations are coincident. Okay. Now, let's do C. So C was, just to remind you here, was these two, right? So let's see what happens on those. So using the same method, in this case we're doing the elimination method, so we can multiply the top by 3, that's what's happening there, and the bottom by 2, and then we end up with this. And now what'll happen on this one is, you can see we got 6x minus 6x, that's 0, -12x minus -12x, so -12x plus 12x, which is 0. But then the constants don't cancel this time. So now I just have an untrue statement, right? Now I've got the statement 0 is equal to -7. So what's going on there? So this one's a little bit different. These aren't exactly the same equations, right? Because, you know, -3 and 4, those didn't end up being exactly the same, right? If we rearrange these into the form y is equal to mx plus b, you'll notice that, well, these things have the same slope, right? They both go up 1 over 2. They have different y-intercepts. So these are different lines, but they have the same slope. So how many solutions does this have? Well, you'd say it has no solutions. And what you can imagine here is if we, you know, had our two lines there. I'll kind of sketch these graphs quickly. So let's say the first one, that graph would, you know, be something like this maybe, where it goes up like that. Now the other one would be, it would have the same slope, right? But it crosses at like, you know, down at -3. So that thing would go like this. Do you kind of get an idea of why we have no solutions in this now? Because these things will never cross. There's never going to be a place where we get these things crossing, right? So if they have the same slope but different y-intercepts, then you're going to have no solutions, okay? So let's just kind of review. If the lines cross, like in the first one, right? So if we get just like what we've been doing, if you get one line here, you know, and one line here, it's where they cross, right? So there's one solution in that case. The other situation was if they end up being the same line, then you can think about the lines as stacked on top of each other, and then there's infinite solutions. And then the third scenario was that they have the same slope, but different y-intercepts, so then they just never cross, right? So then you'd have no solutions. And that's pretty much it for the lesson, right? So here's those again. So intersecting lines, parallel lines, or coincident lines. No solutions, infinite solutions, or like one solution there. Yeah. So you just have to do a little bit of algebra usually on these questions when you get to the hand assignments to figure out if they actually are, you know, if they have the same slope but different y-intercepts, or they end up being the same line, or if they're two different lines. Because if they're two completely different lines with different slopes, then there's one solution, right? So yeah, that's it.